You hear these crazy, almost unbelievable numbers all the time, that building the next big AI costs more than a mission to Mars. So today, we're gonna pull back the curtain and figure out why exactly the future of AI has such a completely astronomical price tag. Just look at this number, $500 billion. That's the rumored price for just one AI project from OpenAI and Microsoft, a supercomputer called Stargate. No, that's not a typo, $500 billion. So the big question is, where is all that cash going? It's not just disappearing into some digital cloud. It's paying for real, physical stuff on a scale that is just mind-boggling. So let's break it down. To get this, you've got to understand one thing above all else. It's all about raw computational power. The industry just calls it compute. You can think of it as the engine for AI. And right now, we are in a flat-out global race to build and control those engines. But here's the thing, access to this unbelievably critical resource isn't spread out evenly at all. In fact, it's creating this huge new form of global inequality, a world of compute haves and have-nots. And when you look at the numbers, the imbalance is just staggering. Right now, the United States controls about 75% of the entire world's AI compute capacity. China's a distant second with 15%, and the whole European Union, just 5%. This isn't just a tech gap, it's a power gap. So what is this compute stuff actually made of? Well, it all comes down to the hardware, and really it comes down to one incredibly powerful and incredibly expensive little component, $40,000. Let that sink in for a second. That's the price for one of these specialized computer chips, the NVIDIA H100 GPU. That's more than a brand new car for one tiny little square of silicon. And the big AI models, they need tens of thousands of them. So why the absolutely bonkers price tag? These aren't your normal chips. They're packed with thousands of cores designed to do AI math all at once. But the real kicker, they depend on super specialized parts like high bandwidth memory, or HBM. And right now, there's a massive global shortage of this stuff. Prices for HBM literally doubled last year alone. But buying all those chips, that's just one part of the equation. There are actually two totally different bills you have to pay for AI, and it's a difference that honestly changes everything. On one side, you have training. This is that huge one-time cost to actually build the AI model. Think of it like building a giant factory. But then on the other side, you have inference. This is the cost you pay every single time someone actually uses the AI, every question you ask it. The factory's never-ending electricity bill. I heard one developer put it perfectly. Training hurts once. Inference bleeds forever. That upfront training cost gets all the headlines, but it's the constant 24/7 cost of running the model that really truly bleeds you dry over time. And the scale here is just wow. A whopping 85% of all AI computing power out there is being used for inference. That's for running the models we all use every day. Only about 15% is for training new ones. The real cost isn't building the factory. It's keeping the lights on forever. And that electricity bill we talked about, it's actually way more than just electricity. There's this whole hidden ecosystem of costs that you need to support all this hardware, and it adds billions and billions more to the final bill. You've got to build and cool gigantic specialized data centers. You have to pay enormous fees just to move and store all the data. And you have to hire an army of incredibly smart and incredibly expensive engineers to make the whole thing work. The chips are really just the tip of the iceberg. So let's put a real number on that electricity bill. The projections are just nuts. By 2028, just running AI models is expected to use somewhere between 165 and 326 terawatt hours of electricity every single year. What does a number that big even mean? Well, to put that into perspective, that's enough energy to power nearly a quarter of every single home in the United States. It's a truly unimaginable energy footprint. So, okay, we've got billion-dollar hardware, never-ending running costs, and an energy bill the size of a small country. Why does any of this matter to you and me? Because compute isn't just a tech resource anymore. It's quickly becoming the new currency of global power.
I've never seen anything like it.
These astronomical costs act as a giant gatekeeper. They put up a wall that is just too high to climb for most startups, for university researchers, and even for entire countries. It funnels the power to build our future into the hands of a very, very small club. And this leaves nations that can't afford to build their own AI with this stark, pretty awful choice. Option 1, become dependent on another country's AI and risk your data and your sovereignty. Or option 2, go without it and risk falling completely behind, both economically and militarily. It's a terrible choice to have to make. And that brings us right back to the central question, which isn't really about tech or money at all. It's about power. It's about who gets to decide what the future looks like for the rest of us. Because when the price of admission is billions of dollars, you've really got to ask, who actually gets a seat at the table? If this changed how you think about AI, subscribe to Logic Atlas. We break down the hidden systems that run our world one layer at a time.